Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning. And we are in our 4th week of our 9-week course. So what work do you need to submit for marking at this point? A reminder that the support questions, the ones with the little pencil icon, are not for marking. They are practice problems. So you can decide which ones to do and how many to do. If you're understanding a concept, it's totally okay to skip questions. You don't have to do them all just because they're there. The answers are in the back of your booklet, so please check your work to make sure you're on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So these you need to do all of, and showing all of your work, your steps, and your thinking, so that I know what it is that you know, and I have a better chance of supporting you if you are struggling with something. So how do you submit your work for marking? Well, there's 3 methods. The first is to scan your work and send electronically. If you have a device, you can use it to scan your work. The Apple devices come with a Notes app that has a scan function, and the Google Drive app is on the Android devices. These are both fairly straightforward point and click options, but if you need some support, I have YouTube videos on my channel that walk you through how to do them in my tech tutorials playlist. Then you can send them to me through email to studentwork@nnec.on.ca and cch2bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second option is to drop your work off into Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-14. I did it again today. 1732, or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. All of our radio Zoom classes are recorded and uploaded to YouTube shortly after airing. So this is a good way to access all of our videos in one place. Also, there are short videos that explain common errors or confusing concepts, which can be really useful if you're struggling with something. Math is a really visual subject, so I strongly encourage you to access the videos. Just listening to the audio is not going to really give you the full experience. So either joining me live through Zoom, whether or not you want to talk to me, you don't have to, that is okay. Or watching the replays on YouTube, another great option. If those don't work for you, let me know and I'm happy to send you a copy of the recordings so you still get the full experience. So if you have any questions or concerns, please reach out to connect with me. My email address is broadwood.slate@nnec.on.ca. My Facebook is B. Slate Wahsa. You can call me at 807-737-1488 or extension 2209 or 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 to 11, so that is not a good time to try to get a hold of me. We are doing lesson 8 today, looking at the compound interest formula. So our learning goals are that at the end of this lesson, you will be able to solve problems finding the principal in situations where interest is compounded, and you'll be able to solve problems where you must find the interest rate and the length of time when interest is compounded. And these are slightly different. So you can identify the giving and missing information in compound interest problems is the first success criteria. The second is that you can use the nth root and guess and check methods to solve problems involving exponents. This is something new and a little bit tricky, but we are going to do it together. And you can solve problems with either the interest rate or the time when the time lengths are missing. So again, this is a little bit of the tricky part, but we will have the tools that we need. When we'll use this in real life? Well, we are identifying the information we have and what we need to find. In life, most of the time, we don't have problems that arise that are like, this is the solution of this problem, and these are the exact tools you need that guarantee you will solve it. That's not how life works. Instead, we have situations where we are trying to figure out what it is that we don't know, what it is that we do need to know, and how to put it all together to make it work. But first, let's activate our brain with some mental math. I don't believe in mad math minutes that cause stress and anxiety in students. They focus on memorization and speed, which are not actual values in math education and in the math world. Instead, we want to have students thinking deeply and logically and using numbers that make sense and are friendly for them. And so this is what we focus on in our class instead of focusing on mad math minutes. So our strategy today is shared groups, and we're going to be doing the problem 745 divided by 25. So often when students are learning to divide, they have a bunch of things and you need to share them out one by one into a bunch of groups. So instead, what we're going to do is we are going to share out things into 25 groups to figure out how many fit in each group. So to start off, we need to make our groups, and you can do this in different ways. And as you can see, they do not need to be perfect or exactly the same. I'm just organizing my information. Okay, so I've got 25 groups. I know because I have 5 rows and 5 columns. That's how I figured out how to keep myself organized. And I'm going to share, instead of going through one by one, I'm going to share 10 in each of these. So if I do 10 in each of these groups, I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230, 240, 250. Okay, so that works. I have 250. Well, I still have a lot more, so I can do another group 10. So if you instead saw that instead of doing in 10, you could have done it a group of 20 to start with and shared 20 out through each. That would work too. You don't have to do the same as I am. You could have done 5s. Whatever makes sense for this strategy for you works fine. That's the joy of this, is that you get to do what numbers make sense for you. So I've now shared a second 10 in each of these groups. So that is going to be 500. Well, if I do another group of 10, that's going to be another 250. So that's going to be 750. So that doesn't work. I can't do 10. There's not enough for 10 in each of these spots. So if I do 9 in each of these spots, I'm not sure. I'm going to do 5 in each of these spots. That feels more comfortable to me. So I'm going to put 5 in each. It maybe is not the most efficient to do 5, but it's not a matter about, it's a matter of doing friendly numbers, and 5 feels friendly to me. So I've done 5. Again, you can count by 5s, or you can just figure it out at the end. So we did 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 10, 15, 20, 25. So far we've done 250, 250, 125. So that is a whole 625. So I still need, wait, if I need 625, I need 745 in total. I need another 120. So I know that another 5 is not going to work, which makes sense because 10 didn't work. So why don't we do 2s? Because 2 feels like a friendly number. This group is small. So if I put 2s in each group, and this is the nice thing about this, is that you don't have to do the same thing. Like I know when I was learning, it always felt like I was sharing by 1 and I only had to do by 1 always. But if I'm putting the same amount in each group, that's the whole point. It doesn't matter. Okay, so 2 in each group. So that's another 50. So I'm at 675. So if I do another 50, I'm going to be at 725. So I can do another 2 in each. So I put another 2 in each of them, which is going to be another 50. So that is now 725. Well, I need another 20, but I don't have, that's not enough. If I put 1 in each of these, that's not enough to get to all 25. So that means I have a remainder of 20. So I can just leave that as a remainder of 20. So now I think, okay, so then how much does that get left in here? So we have 10, 20, 25, 27, 29. So each group has 29 with a remainder of 20 left over. Which if it's a remainder, so you could also say 29 and 20 out of 25, which is 29, and 4 out of 5, which is 29.8. Those are all also totally valid answers. All of these 4 different ways of saying the same thing in slightly different ways are totally fine, depending on what you know and what you're comfortable with. So that is how you can share out in groups. With bigger numbers, it can be a lot of sharing out, but it still just works. Okay, what information do we need from prior lessons? I just want to remind you about compound interest, which we covered in our previous lesson, and now we're diving into the formula and manipulating it a little bit deeper. But reminder that it is calculated on the principal and the interest earned. So it's not just the principal like simple interest. It has exponential growth because it grows quickly because you're earning money on top of money. It is really great for investments. You earn really quickly, but it is not great if you are borrowing money because then you end up paying interest on interest, which is not good. So our compound interest formula is A equals P times 1 plus R over N, the exponent NT. Remember, you could have an old booklet that is A equals P times 1 plus I to the exponent N. We're not using that. It's the same thing, though, we went through in our previous lesson about how these two are connected and how they both get you to the same place. They just look slightly different. But A is our final amount, P is the principal amount invested or borrowed, R is your interest rate, which is a percentage as a decimal, and N is the number of compounding periods per year, and T is the number of years, the time in years. We also need to remind you about compound frequency. So the more time we compound, the more time we calculate interest. And this is less than a year, these frequencies. So we need to know the language. Annual means 1, semi-annual means 2, quarterly means 4, monthly means 12, weekly means 52, daily means 365. So these are the ways you need to be able to translate this language. Okay, so that's what we've learned before, but now let's activate our new concepts. This math is all around us again. We are trying to, today we're looking into, in terms of asking the questions, how much should I invest in order to just earn a certain amount of money? How long do I need to invest in order to earn a certain amount of money? Or what interest rate do I need to earn a certain amount of money? So instead of just saying, these are the situations that I have, sometimes we can figure out what we want based on the information that we have. So first, if we were to find the principal, this is, so this formula, no, it's the same formula, but we're going to be using it in slightly different ways. This is on page 16 of your IL booklet. So the real life context is that you would use this method when you want to find out how much you should invest now in order to earn a certain amount over a set period of time. So if you know you want $1 million, how much do you need to invest? Something like that. So let's look at this example. A person wants to have $10,000 in 6 years. They can invest at 3% compounded semi-annually. What amount do they need to invest now to make that happen? So again, we're going to go through and see what information we have and what information we're looking for and how to solve for that. So, first off, I forgot to mention, this says compounded semi-annually. So we know that it is a compound interest question. A simple interest question will not say compounded. So if it does not say compounded, you know, it's a simple interest question. If it does say compounded, that it tells you how often your interest is compounded, that means that it's a compound interest question, and we're using this formula. So then we have A equals P times 1 plus R divided by N to the exponent NT, and we have our variables that we need to find. So A, the person wants to have $10,000. So in this case, we know A, we know how much total amount they want. So that's $10,000. T is 6 because we know they want it in 6 years. R is 3%, which is 0.03. Semi-annually is our N, which is 2 because it's compounded semi-annually. And the question asks, what amount do they need to invest now? So that is your principal. So that is what we're looking for in this case. So now we have our variables. We know what we're looking for and what we need to know. So we're going to put that into our formula, and we have 10,000 equals P, because that's what we're looking for this time. So we're leaving the P there, times 1 plus 0.03 divided by 2, all to the exponent 2 times 6. So then we can work that out, either putting it all into a Desmos calculator or a calculator on our own, or if you're going to do the steps, you can do the steps. So then the trick is with this is that you have, because we're isolating, we need to isolate for P. So you can't just put it all into your calculator in this same format because we need to figure out what P is. So 10,000 is equal to P times 1.015 to the exponent 12. Well, in order to isolate for P, we need to divide both sides by what's on the same, what we're multiplying by P, right? Sorry, that's badly drawn line. So we're going to multiply by 1.015 to the exponent 12. We do it on one side, we have to do it on the other side. And that's how we get to P equals 10,000 divided by 1.015 to the exponent 12. So then we do that on our calculator and we get P equals $8,363.87. So we check how we answer the question. Well, the question was, what amount do they have to invest now to make that happen? So therefore they should invest $8,363.87 now in order to have $10,000 in 3 years. And that's how we find the principal in this sort of question. So if we are finding the interest rate, so we're trying to figure out if we're compounding, we need to find the interest rate. We need to do things a little bit different. So when we're finding principal, we just need to rearrange our formula, and it's fairly straightforward in terms of just using algebra to find out P. But with our interest rate, we need to pause and remember a skill that we may or may not have. That is a tool that we need to use. So we just need to look at algebra with exponents a little bit, because this is a little bit different when we're trying to solve. We have a variable with an exponent. So in this situation that we're looking at, we have a variable that has an exponent. So for example, x to the exponent 5 is equal to 32. Well, that means that we have a number times number times number times number times number. And that's what x equals 5 to the exponent 5 is. And so 32 is equal to a number times a number times a number times a number times a number. That's what this is asking. They're saying. So x to the exponent 5 equals 32 means that we take the fifth root of both sides. So we often take the square root of sides. That's something that we don't think about too much. But we can also take any number of roots. And so what the fifth root is asking you what number times itself 5 times equals this number. And you have a button on your calculator to do this. So then you can figure out that x equals 2, because 2 times 2 times 2 times 2 times 2 is equal to 32. These are not things that most folks know all of these in their heads. Some of them might be more familiar than others, but it is something that many of us use a calculator for. So how this works in general, the square root uses 2 times in a multiplication statement gives the original value. So if you square root something, the square root of something is, you do that times itself twice, you get that number. If you do the cube root is used 3 times in a multiplication statement, it gives the original value. So you do the cube root times cube root times cube root gives you that number. So the nth root is what we call it when we don't have a number in specific, when we're talking about it in general. So the nth root uses n times in a multiplication, gives the original value. So this is the tool that we're using for the 5th root, for the 100th root, whatever, is telling us that that little number on our root sign that is outside our root sign is the nth root, is the number root. Tell us how many times we're going to be multiplying that number in order to get that whole value. So let's look again with some more examples. So x exponent 3 is equal to 125. So that means the 3rd root, the cube root of x exponent 3. So that means that we end up with just x. The cube root cancels off the exponent 3 is equal to the cube root of 125. And so now let's find your calculator button. So often it is, so we're looking for the nth root, so we get to decide how many roots we're taking. So it's often the second function of your exponent button, which if your exponent button is x to the exponent y, your nth root might look like x root. So x before a little root symbol. Now, again, as it is the second function, this is probably written above your calculator button. So let's look at Desmos and see it. So here, this is my exponent button. Here on Desmos, we have the nth root. So it shows us here is the button that we're going to press. If I click it on Desmos, it then shows me, okay, I have to put in the number, the nth root, the number that I want to take the root of. No, the number of roots that I want to take. That's how I'd say it. So I put in a 3 here, and then underneath I click and I get 125. That is the base that I am saying what number times itself 3 times is going to equal 125. And the answer is 5. So it's a little awkward to say, and it's a little awkward to get your head around. So no worries if it takes some practice, that is totally fine. So x is equal to 5 in this state. So if we do y to the exponent 8 is equal to 65,536, definitely not something that I know. So again, if we go to our calculator, we're going to do our 8th root of our number, 65536. You can see that the answer to that is 4. And this is how the steps are that you would write it out. You take the 8th root of both sides, and then y is equal to 4. So 4 times itself 8 times gives us this 65,536 number. And the last one, number 3, a to the exponent 15 is equal to 325. So we take the 15th root of both sides, and we end up with a equals 1.4705. You don't always get a whole number. Not everything has a perfect nth root, which makes sense. So I'm going to just show you this, so what your calculator might do. So again, 15th root of 325. And so here you can see you have a long decimal. Generally rounding to 4 or 5 decimal places is a good idea. Is probably gives you enough information. If you want to use this in something and you want to be precise, you can leave this in your calculator and it can hold all the decimal places. Okay, so that is how you use your nth root. We are going to use that tool now that when we're finding the interest rate. So then a quick note before we dive in, if you have a booklet that is before 2021, before I was able to update it, and how you know this is along the bottom of your pages. If it says updated in 2021, updated 2021, then you have an updated version. If it doesn't say that, it could say a whole bunch of random other different things. Then you have it before then, and you're probably using the a equals p times 1 plus I to the exponent n formula, and they just walk you through how to guess and check. They don't show you how to find the nth value because it's tricky when you can't distinguish between your rate and your compounding periods. So that's fine. You can use the guess and check if that's what your booklet is. That's totally fine. If you want to use this method, even though your booklet doesn't say that, that is fine too. Okay, so what are we actually going to do? What is the skill we're working on? So we're finding the interest rate, which is our R. So we're just finding the interest rate. We're going to need to use the compounding periods, but we're looking for the actual interest rate. So when would you use this? Well, you would use this when you want to find out what interest rate you need to earn a goal amount when you have a set amount to invest now over a set period of time. So you know how much you want to invest, you know how long you want to invest for, you know how much you want to earn. So this is what interest rate are you looking for? So the example we have is a person wants to have $1,500 after 5 years. They can invest $800 now in an investment that compounds quarterly. what interest rate do they need to make this happen? So again, this says that it's compounded, so we know that we can use the compound interest formula. If it doesn't say it's not compounded, we can't use it. Then we know what our formula is and all of our variables. So we want to have $1,500. So that's our A. We want it after 5 years, so that's our T. We have $800 now, that's our P. We can compound it quarterly, so that is our N, 4. And this is something that the bank generally tells us, so it's not something we usually get to pick. And we're looking for, the question says, what interest rate do you need now to make this happen? So that is our R that we're looking for. So we put in the variables that we substitute in the amounts that we know, the values that we know. So we have 1,500 is equal to 800 times 1 plus R divided by 4 to the exponent 4 times 5. So then here you're going to have to do some steps because we're going to be isolating for R, but we need to do some steps in order to do this. This is algebra to isolate for R. And if you need some support remembering how to do this, go check out my YouTube channel or let me know and I can help you with practicing this. So we have 1,500 equals 800 times 1 plus R to the, R divided by 4, all to the exponent 20. So we're going to divide both sides by 800 in order to isolate. And how you know how to isolate is that you actually are doing it in the reverse order of operations. When you want to isolate for a variable, you do the things in the backwards order from Desmos in order to get closer and closer to just having your variable. So 1,500 divided by 800 is equal to 1 plus R divided by 4 to the exponent 20. So that is 1.875 is equal to 1 plus R over 4 to the exponent 20. So now we can see that what we have left is in our brackets. So now we need to deal with that 20 exponent. So we're going to do, so remember that the square root is the inverse of x squared. So that means we have an exponent of 20. So that means we need to do the 20th root is the inverse of x to the exponent 20. So here we have an exponent 20, so we're going to do the 20th root. That's how we know what root we're going to do. We do it to one side to cancel off. That means we have to do it on the other side to keep ourselves balanced. So then we have 1.0319 equals 1 plus R divided by 4, using our calculator button to do our nth root, remember? And then, sorry, I'm running out of space, so I have to move it over here. We're going to subtract 1 from both sides in order, again, to isolate for R. So we're left with 0.0319 equals R divided by 4. So we're going to multiply both sides by 4 in order to isolate again for R. And we get 0.1277 equals R. And so that as a percentage, we have R equals 12.8% is the interest rate that we would need to have for this situation. So there's a few more steps when we're finding our interest rate. And it can be easy to make mistakes along the way. So be careful and go slowly and be paying attention to what you have and what is the next logical step. All right, so then our next situation is if we're finding the time length in T. We're trying to figure out how long we have to invest in order to get what we want. But again, we need to pause and do some more algebra look in order to have the tools that we need to find the time. So this algebra piece is when we have a variable in the exponent. So last time we had a variable with an exponent, but this time we have a variable in the exponent, and so it is different. So that means, for example, we have 4 to the exponent n, which is equal to 64. So that's saying how many times does 4 times itself equals 64? So that is what we're looking for. That's what this exponent means. So we have to use guess and check. We don't have the tools in this course to figure out how to do this exactly using a button on our calculator. It's it's more complicated, and that's something that you dive into if you're interested into the grade 12, some of the grade 12 courses, not all of them, but some of the grade 12 courses dive into logarithms, which is what you need. So we are going to use guess and check and get pretty close, and that's going to be okay. Sometimes that's the best tool that you have. So what that means is we're going to say, okay, we're trying to figure out how many 4s get as close as we can to 64. So we're going to just start using what we know. So 4 to the exponent 1 is equal to 4. Okay, not enough. 4 to the exponent 2 is equal to 16. Okay, still not enough. We need more 4s. 4 to the exponent 3 is equal to 64. Oh, that's what we wanted. Okay, so we don't need to do it anymore. So what that means is that 4 to the exponent n is equal to 64. How you write this is that now you say, because 4 to the exponent n is equal to 4 to the exponent 3, we replace this 64. We are changing it and giving it a different version of itself. So it's like one of those, it's the same thing. 4 to the exponent 3 and 64 are the same thing, they're the same value, but we're just calling it something slightly different. It's like we can say 1/2 is 1/2 or it's 0.5. They're both a half, they're just look slightly different. So then when we have the same base, now we can say that n is equal to 3, because if our base is the same, then we can say, well, if our base is the same and they're equal to each other, then our exponent has to be the same. So n has to equal 3. So our steps in terms of what we need to do, we use guess and check to make sure the base on both sides of the equation is the same. That's the first thing that we need to do. That's our goal, is we're trying to get the bases to be the same, so that then we can say that the exponents are equal to each other. And that's our second step. This is tricky, and we're going to do a bunch more examples. So if we have x to the exponent 3 equals 100, so that means that we're saying 3 times itself, how many times gets to as close as 100. Now, you can use a calculator. That's fine. You don't have to write it all down. You can write it down if that helps you, but you can just use a calculator, and that is okay. I'm going to write it down so that we can see and so that we have that visual reminder, but you don't have to write it down if you don't want to. If that doesn't work for you, it's okay. So I knew that 3 to the exponent 1 and 3 to the exponent 2 were going to be too small because I'm trying to get to 100. So I did 3 to the exponent 3, which gets me 27. I'm still a fair ways away. So I'm going to do 3 to the exponent 5 to just try. And I see that that is 243. So I'm too big. So I'm going to go back to 3 to the exponent 4, and that's 81. Well, I'm close, but not. I'm going to see if I can get closer. So what that means is I'm going to start putting decimals into my exponent. So if I do 3 to the exponent 4.5, I get 140.3. And I'm doing this in my calculator. So I'm doing 3 to the exponent 4.5 on my calculator, and I get 140.3. That's how I'm finding this out. So I'm going to do it smaller. So I'm going to do 3 to the exponent 4.1 equals 90.4. Okay, so I'm closer, but I'm still going to see if I can get a little bit closer. So if I do 3 to the exponent 4.2 equals 100.9, that looks great. That looks pretty close. It's okay that I'm a little bit bigger. We're trying to get close. That is our goal. So that means that 3 to the exponent x is approximately equal to 3 to the exponent 4.2. So x equals 4.2 is what we would do in this situation. And that, again, gives us a really close approximation. It's okay that it's not exactly right. Okay, so now another example. 2 is equal to 1.0275 to the exponent n. Okay, so our goal is to get as close to 2 as possible. So my base is 1.0275. That doesn't seem very nice, but those are the kind of bases that we're going to be looking at. And we're going to try to get that as close to 2 as possible. So if I square that, I get 1.0558. I'm like, whoa, that's not very big at all. That's not very much closer to 2. So I'm going to guess, I'm going to put 5 as my exponent. 1.0275 to the exponent 5, and I get 1.1453. Well, that didn't get me very much bigger, but much closer to 2. So I'm going to guess a lot bigger. And I say 1.0275 to the exponent 20. And that gives me 1.7204. So I'm still a lot closer than I was before, but I still have still a ways to go. So I'm going to guess 1.025 to the exponent 25 equals 1.9704. Okay, I'm getting better. Then if I guess 1.0275 to the exponent 26, that equals 2.0245. That's pretty good. I can, if I want to, I can go back and say 1.0275 to the exponent 25.5. That equals 1.9973. If I want to, I can. Going with 26 would have been okay too. Like, you have to call it in terms of how close you're trying to get. So that means that 2 is the rough equivalent of 1.0275 to the exponent 25.5, which equals approximately 1.0275 to the exponent n. So 25.5 is equal to n. And that's how this guess and check works. Again, it's tricky, it takes some time, but you can do it. Okay, so again, we're going to go back to how we apply this in today's situation. Again, if you're using a pre-2021 IL booklet, they're fine n using the guess and check method, which is similar but slightly different. But we're using the same type of guess and check method. So if we're finding the time length, t, in a compounded interest situation, so this means that you want to find how long you need to invest in order to earn a certain amount of money. So a company invests $25,000. They'll pay 8.25% compounded monthly. How long will they have to leave the investment for it to double? So it says that it's compounded, so we know we can use compound interest. And now we need to fill in our variables. So we're investing $25,000, so that's our P. We're paying 8.25%, so 0.0825. It's being compounded monthly. Then we want the investment to double. So that means that we want twice the amount. So our A is $50,000 instead of $25,000. So that's a little bit tricky because it's not a number. You have to interpret the word double. And then T is our time, how long we're trying to figure this out for. So then we put our numbers in. We have 50,000 equals 25,000 times 1 plus 0.0825 divided by 12, all to the exponent 12t. So that means we have 50,000 divided by 25,000 equals 1.00675 to the exponent 12t. So we end up with 2 equals 1.006875 to the exponent 12t. Okay, so now we're guessing and checking. Our goal is to try to get as close to 2 as possible because our t is in our exponent. So 1.006875 to the exponent 10. I've just picked 10. These numbers I'm just guessing randomly to start with, and then I hone in my information. So that gives me 1.0709. That is not very close to 2 as possible. I'm going to need a much bigger exponent. So I'm going to try 20. 1.006875 to the exponent 20. And that only gets me 1.1469. So again, I'm going to need a significantly larger. So I'm going to go up to 50 is my exponent. 1.006875 to the exponent 50 equals 1.40686. Still not big enough? Okay, so I'm jumping up to 100. So 1.006875 to the exponent 100 equals 1.9841. Okay, that's a lot better. Now I can fine tune it. 1.0086875 to the exponent 110 is equal to 2.1248. So that's too much. So if I do it 1.006875 exponent 105 equals 2.0532. Maybe you're stop there. Maybe that you're happy with that. That's okay. That's pretty close. If you want to do more specific, 1.008687 exponent 1.101 is 1.9977. Maybe you're happy there. Again, it's okay if your numbers are slightly different than mine. If I can see your work, that helps me understand. So that means that this can translate into 1.006875 to the exponent 101 is equal to 1.006875 to the exponent 12t. So our base is now the same. That means our exponents are equal. So 101 equals 12t. So I need to isolate for t. So that means 101 divided by 12, which means that time is 8.4. So the company would need to invest for 8.4 years. And that's how you find the time length. So again, it's a little tricky. It's definitely different, more steps, but you just need to find a system that works for you. All right, now you can do the support questions on page 18, questions 1 through 4. I strongly encourage you to do all of these support questions, as this is an awkward one. These ones have some finesse to them. All right, so we probably have time to do one practice question. We'll see. So Jiva is 10 years old. His parents have decided to invest some money for his future so that he will have $15,000 at age 18 when he finishes high school. If the investment can earn 6.6% compounded monthly, how much will his parents need to invest? So compounded monthly means we're using a compound question. So then we have our variables. Again, it doesn't matter the order that you write them down. If you write them down in the same order, then you're more likely to remember them. So A is how much we want to have. So that's $15,000. P is how much we need to invest. Well, that's what we're looking for. Our rate is 6.6%. So that is 0.066. Our N is 12 because we're compounding monthly. And our time, well, it's in 8 years because it's 18, take away the 10 years that we currently are at. So that's 8 years. So then we do A equals P times 1 plus R over N to the exponent NT is equal to $15,000 equals P times 1 plus 0.066 divided by 12 to the exponent 12 times 8. So what you can do if you want to just do this all on your Desmos is you can do $15,000 and then just divide it by this whole thing. So 1 plus 0.066 12 to the exponent 12 times 8 equals P. That is another way of doing it. So without having to just doing all the rearranging and then without having to do any of the calculations and rounding, this is another option. But again, you do what makes most sense for you. And put it in, and then we get, oh, I'm like 32. 32 doesn't make any sense. That's because here I forgot to put in, I missed the 2. So it's really important because your calculator makes mistakes all the time. It just does what you tell it. So if you make a mistake, it's going to make a mistake. So you need to look at your numbers and say, this number doesn't make sense. Where did I make a mistake? Okay, here's where I can put in my answer. So $8,859.56. So that's how much Jiva's parents needs to invest at this time in order to have $15,000 at age 18. So still better to invest something than to invest nothing, even if you're doing it what society might deem as late. All right, we don't have more time to do more practice questions. If you want to do more practice, let me know. I can send you some questions or we can talk through it, or you can check out some of my other videos from past years. I may have had more time, just how things end up. So let's consolidate what we've learned today. So we've dissected a compound interest problem. That's really what we've been doing. So we know that the word compound must be in the problem. We must be able to identify what information is given and what you are being asked to find. That is the second thing that we need to do. If we're finding the principal, then we just need to rearrange to isolate for P using algebra. If we're finding the interest rate, we need to use the nth root to isolate for R, as well as algebra. And if we're finding the time length, the T, we need to use guess and check to force the bases to be the same. And then we can use the exponents can be set as equal in order to isolate for T. So they're all slightly different. So you need to practice. So hopefully you can identify the given and missing information in compound interest problems. That's the first part. And the second part, you can use the nth root to guess and the guess and check methods to solve problems using exponents. So that's a little bit extra. So that then you can solve problems where either the interest rate or the time length are missing, because those ones are the ones that are a little bit more complex using these other tools. So if you have any questions, if you're working through things and you're not getting the answers that are in the back of the book, please reach out and connect with me. I'm happy to walk through questions and figure out why. Is it just a calculator error? Is it an order of operations error? Is it a decimal error? Something like whatever. We can walk through to figure out where it is that you are making mistakes. So please, please reach out so that we can do that together. Give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca. That's spelled BRONWYN.SLATE@nnec.on.ca. You can send me a message at Facebook at B-Slate Wahsa, or check out this video as well as all my other videos if you'd like on YouTube, where my channel is also called B-Slate Wahsa, and we have a playlist called MBF3C where all of our lessons are and some of the other resources and tools that you might need. Thank you so much for joining me today. I hope you have a lovely day. Mogwitch.